Hello, I'm Andy. I've been interested in astronomy and space exploration all my life. I've been involved with various astronomical societies. I write articles for websites and magazines, and I lecture on such topics as gravitational waves and black holes. Welcome to Space Oddities.
Welcome to Space Oddities. My name is Kareem. I'm the Public Events Coordinator at the Royal Astronomical Society of Canada's Montreal Centre, the Astronomy Prof here at John Abbott College, as well as a presenter every Tuesday night on the Global Star Parties by Explore Alliance. Our wonderful panel here is ready to share with you the world of astronomy and space, all the news, all the topics of the day, and we hope you'll join us.
Hello, my name is Keith Mosley and I did a degree and a doctorate in Earth Sciences at the University of Birmingham before becoming head of geology and head of physics at Monmouth School in Wales. I retired in 2015, but I carried on working for the Open University as an associate lecturer in astronomy. But now in retirement, I write educational materials for schools in Britain and also in Europe.
Hi, I'm Mary. I'm an amateur astronomer, astrophotographer, astronomy sketcher, and an astronomy and space artist based in the UK. I have a really busy talk schedule talking about astrophotography and lots of other areas of astronomy. I run astronomy sketching workshops, I do outreach events, and I also do astronomy writing for magazines and books. I'm really looking forward to seeing you guys on Space Oddities.
Hi, I'm Daz and welcome to Space Oddities. Over the last 2 years I've been fortunate enough to work with this panel on astroradio.earth, talking space to the world. I also produce my own educational / documentary style programs, and being a jack of all trades and master of none, the content varied a lot. I would like to extend an invitation to you to join me and the panel on Mondays 8 PM UK time, where we can all sit and chat space. See you soon.
Hello, this is Pete Williamson. I'm a retired professional astronomer, founder of Astro Radio and Solar Sphere Astronomical Music Festival. Sadly, Astro Radio is no more, and this panel that we're all going to be part of was born out of Astro Radio's Reach Out and Touch Space. So that's me introducing myself. There's nothing else to say. I'm a retired professional astronomer, still doing the odd talk, not doing too much these days, but still doing the odd talk, and I'll contribute to this panel from time to time. So I hope to see you online very soon. Thank you very much.
Hi, and welcome to the show. My name is Dave, and I reside in Liverpool, UK. I have followed all things space and astronomy since I was a little child back in the 60s. I've been a member of the Liverpool Astronomical Society for 46 years, and currently I am the Observatory Director. I'm involved in outreach work, and like many of you, I have that passion to share my knowledge with all like-minded people. Welcome aboard. I hope you enjoy the show, folks.
Hi, I'm Bernard. Welcome to Space Oddities. I'm a science writer. I'm published by Springer Publishing, and I focus mainly on planetary science and space technologies. But I'm also a science speaker. I do a lot of public outreach events for astronomy organizations in the UK and elsewhere. We're going to have so much fun on Space Oddities, so I hope you'll join us.
Hi everyone, I'm Lou, and welcome to Space Oddities. I'm a planetary scientist and professor of astronomy at Marymount University. I spent most of my career working on NASA space missions, working on NASA ground systems, and what I love most, creating space science education programs that reach people all over the world. I hope you'll join us as we explore the mysteries of space together on Space Oddities.
Hello, my name is Roger. I live in the West Country in the UK, and since I've taken early retirement, I've taken up my love of astronomy back again, and I'm getting quite into astrophotography, especially lunar, solar, planetary and deep sky. So hopefully if I can help anyone along with hints and tips, I may be able to give you some advice later on as we progress through our groups in the many weeks and months to come. Thank you.
Hello, I'm Rachel and welcome to Space Oddities. I'm here because, like the rest of the panel, I'm passionate about astronomy. I love to share my passion with children, and I do regular outreach events and talks with children and young adults. I also write articles for a magazine for young stargazers, along with taking pictures of the night sky with my husband. I hope you'll join along for the astronomical fun. See you soon.
Hello, I'm Simon and welcome to Space Oddities. I've been doing astronomy now since the year dot. I've been a member of several clubs and currently I'm helping out run Bath Astronomers in Somerset. I enjoy repairing telescopes and running outreach, so I hope you're going to enjoy Space Oddities as much as I am.
Hi everyone, my name is Michael. I'm an amateur astronomer from the Midlands, and I'm a member of the panel of astronomers on Space Oddities, a new weekly chat show with a difference, featuring a panel of experts discussing all things astronomy. I've been interested in astronomy for most of my life. I enjoy learning everything there is to know about this fascinating subject. I have been a keen member of astronomical societies, including working at council level. Although not an active observer, I enjoy following the various space exploration programs from around the world. I do hope you can join me and our panel of experts on Space Oddities.
Good evening and welcome to Space Oddities. If you're new to Space Oddities, you are most welcome indeed, and thank you for joining us. Here is our normal Monday night show with my esteemed colleagues on the panel here. How are we all today?
Oh, good, thank you.
All good, thank you.
Lovely, thank you.
Yeah.
Okay. We should send best wishes to Bernard, who unfortunately has contracted COVID. So Bernard, if you're watching or listening, get well soon, mate, and come back soon. So we've got a little bit of a change to what we were planning tonight because there was an announcement this morning that at 10 p.m. UK time tonight, President Joe Biden is presenting the first science image from the James Webb Space Telescope. So what we've decided to do, we had already planned to go live tomorrow night to look at and chat about the images that are going to be released tomorrow, but this sort of took us by surprise. So what we're going to do, we're going to stay on the air, as it were, for the next hour, and then we're going to go away for an hour and we'll leave the stream running and we'll come back and share with you Joe Biden, presumably from the White House. Has anybody heard where he's doing it from?
Yes, it is a White House briefing.
Yeah, it is a White House briefing. This is not in some corner shop somewhere then. Right. Okay, so it'll be live from the White House here on Space Oddities at 10 p.m. UK time tonight. We don't know what to expect. We don't even know which of the images he's going to present. So
it's going to be a deep field.
Oh, it's going to be deep field, is it? Thank you, Simon. Yeah. Oh, great. So that should be spectacular then, shouldn't it?
Look forward to that.
I think that which of the images are you looking forward to seeing, panel, the most?
Oh, Stefan's Quintet.
Stefan's Quintet.
Yes, I imaged that a few years ago, and but using SLU to mention it, a programmable a remote telescope site, and we managed to catch Stefan's Quintet very nicely. Took a few shots and stack him, but yeah, looking forward to that. In fact, I'm looking forward to everything, to be quite honest.
Yeah, me too. I guess, Kareem, you're looking forward to WASP, are you?
I'm looking forward to WASP just to see whether we're able to confirm some of the things we think about that exoplanet. But honestly, I'm actually more looking forward to the Carina Nebula. I want to see it in infrared with that resolution.
Yeah, that should be amazing. That really should be amazing.
Like what Daz was saying, I've gotten to use a few of the LCO remote telescopes, and I've done Carina Nebula, but I'm not too happy with my processing of it yet. Right. But I can't wait to see that level.
Me neither. What about you, Rachel? Any one of the images you're looking forward to?
Don't know. I think I'm like that puppy that's just like running around the room waiting for everything, and they don't quite know what they want.
I think we're all a bit like that. Yeah.
I want a really good image. I want an updated image on GNZ11. That's what I want.
That should be really good. Roger, any preference?
No, I'll just be amazed at everything that it comes out with. I'm not fussed.
Right.
We'll just get blown away with it all, I'm sure.
Right. And Simon, I saw you nodding in agreement with Daz. Is Stefan's Quintet for you?
It will be, man. That's mainly from the outreach, because it's a real grabber for visually for everyone, and you don't need much science to understand its beauty as well as its complexity. So it's a great one for going out and grabbing the audience. So I'm looking forward to that one.
Great, thank you, Steve.
Well, I was going to say glibly that I'm just looking forward to the first image, but actually I am, because I think the deep field, because it will be a really, really good comparison with what Hubble achieved, to instantly gauge how good James Webb will be beyond it.
But will it? Because this is data from the first 5 days of operation, so there's hardly any integration time on this one, and they did, was it dozens and hundreds of hours to do the ultra deep field. So it's not kind of comparing apples with pears, really. Or apples with apples. Sorry, is it?
But it could point out to what we could
teaser
in the future. Like,
as a teaser, I think that's amazing. Yeah.
Yes. What about you, Michael?
Yeah, again, the deep field. I'm with Steve on that one, definitely. I was fascinated when we had Hubble deep field images, and just looking forward to what James Webb can do.
Right. Okay. Of course, what we should remember is that the James Webb Space Telescope, a wonderful instrument as it is, and its potential is enormous, and it will, I'm sure, revolutionize our understanding of certain things about the universe. It's only the first in a whole new generation of Earth and ground-based telescopes that are being constructed over the next decade. And we can expect equally revolutionary things from a number of different telescopes. This is by way of giving a plug in advance for the program that Daz and I are creating, the video that Daz and I are creating for Space Oddities at the moment, coincidentally, on the next generation of telescopes. So that video we'll put on the Space Oddities channel as soon as it's done, which hopefully won't be
shameless plug.
I'm very good at shameless plugs. Okay, so anyway, if you have any questions or comments or anything, please do put them in the live chat, and we'll keep an eye on those and try and answer your questions. Simon, was it you from Bath Astronomers who asked a question about the intense gravity of neutron stars actually cracking them open? Was it you?
It was a leading question, but yes, it was me.
Yeah, it was a leading question because I said at the time that no, but I was forgetting magnetars, of course, because magnetars have such an incredible magnetic field that can actually crack a magnetar, which is an extreme neutron star, right open. They think because of its violent outbursts, but normal neutron stars probably don't do that. But magnetars can. So that's just to answer your question fully, Simon. So there we are. Okay, so what we're going to do now, as always, we're going to go straight to Roger for his roundup of the night sky. So what have we got in the night sky coming up, Roger?
Well, you're about to find out if you can wait.
Of course we can wait.
All right then. Okay, everyone, here we go for the week, the 11th to the 17th of July. And as you can see, we're getting up near to heading towards the full moon, which is on Wednesday. And it will be a super moon. I know. It's known in America as the buck moon.
The what? The buck moon, right.
The buck moon, because that's when the deer loses its antlers, when they've been rutting and stuff. Anyway,
right.
Enough of that.
Exactly.
But yeah, the phases of the moons here are mine, I'm afraid. So, shameless plug. Right. And I thought, while I was doing this presentation, here's a current view of the sun today. And as we are getting towards somewhere near to the maximum in a few more years, this is the activity, and it's certainly gaining a lot of spots across its surface and more appearing round from the limb.
And this is purely an optical wavelength, I suppose, Roger.
I was using a refractor with some Badar solar film, which you must use. Yeah. It blocks out about 99.5% of the light, so it is suitable for visual use as well. But I used what they call a solar continuum filter, which is basically in the green filter, which helps get the contrast of the sunspots from the surface more defined. And as you can see, it's picked out a lot of interesting detail there.
You've got some really lovely detail there in those sunspots. So we're looking at the larger one of the pair at the bottom. I presume we're looking at something the size of the Earth there, aren't we, really?
Oh, probably several diameters. You could probably get a couple, probably a couple in inside of that dark area there, I would have thought.
And it's amazing thought, isn't it? You can't, just looking at this, you can't grasp the scale that's, that whole thing is much bigger than the Earth.
You can fit 110 Earths across the face of the sun. So.
Right. And about 1 million inside.
If you can find a little lid to open, pour them in. Yeah.
Doesn't it have a ring pull? I'm sure I read that somewhere. So lovely image, Roger. What have we got next?
Right. Okay. So I'm afraid we're down to just 4 planets during the morning now. Mercury is now lost into the brightness of the daylight times, and gradually coming across, and Saturn will become more obvious as it comes into the latter part of the year for evening observation.
Right.
Okay, and we've got. But last week I was mentioning all about Comet Pan-STARRS. It's still in the constellation of Ophiuchus. It's coming down towards the horizon. And during last week, I got a couple of nights where I took some images. And here's one of them. This is where I've kept the picture of the comet stationary as it moved. I got the stars tracking.
Nice effect though, isn't it? I like.
It's a nice effect.
Yeah.
And it appears almost as if the head of the comet is offset to the nucleus. I couldn't quite get too much detail on that, unfortunately, but
that's strange.
I managed to capture it, and then I tried to take a closer in view with a bit bigger telescope, and it's a little bit wishy-washy, not so clear, but it gives you a bit more definition to the tail there. Right, I'll quickly move on from that. Right, so anyone in the southern hemisphere, this is what you'll be getting, and as winter progresses through over to beyond Venus in the east, you'll gradually see Orion rising out of the sky. And obviously, because you're in the southern hemisphere, you've got Mars, Jupiter, and Saturn way up in the high altitude, so better visibility for getting some lovely pictures of those planets as well. Although Mars won't be at its best until about December this year for its next opposition. And that's about all I have for this week. Thank you very much.
Thank you very much, Roger. We've had some reports of the stream's breaking up a bit, viewers. So if you're having problems with the stream breaking up a bit, can you please write something in the comments if you're having problems, and let's see how widespread the problem is.
I think they mean it's during the
having problems. We don't normally have problems.
Yeah, I think it's during the playing of the.
If anybody's having breakup problems with the feed, if it's not working properly, then please tell us in the comments.
Yeah, I think they're talking about actually
Rachel, if you could let us know
in the intro.
If that's the case, not that there's a lot we can do about it if that's the case, because that's down to YouTube. But anyway, let us know if you're having problems, and if you are, apologies, but I don't think there's a lot we can do about that. Just have to hope it corrects itself. Okay, moving on then. So, Daz, have you got some news for us this week?
Well, it's been quite a bit of a slow week, to be quite honest. There hasn't been that much going on. Of course, the main news starts tonight, as we just found out, rather than yesterday. So everyone's been gearing up for tomorrow.
Yeah.
There are some news items that we have missed over the last couple of weeks. One of them, unfortunately, is about 16 Psyche, the Psyche probe. The probe is now, which is due to launch later this year, has now been delayed until the earliest 2023. They're finding that the actual probe's been built. There have been delays due to COVID and things like that, which is expected. But also they're now finding that the actual brains, the computer side of it, all the instrumentation, which they were due to test at NASA, because the actual computer side of it was produced by a contractor, and I can't remember their name offhand. I will find it in a second. They've sent all the gubbins over to NASA, where it was going to be put on a test bed and put on a chassis, not a replica of the actual probe, but it's just a flatbed chassis where they can plug all the things in and all that, and test everything to it's at the end, and they'll be using telemetry to see if everything's working, all that. It seems the problem is that the things won't interface together, which is a big surprise, in the fact that you would have thought somebody would have checked this before they sent all the stuff over. And so nothing's actually working at all the moment. They're having some investigation into whether, to find out what's gone on, why this has happened. Also, it's to see whether or not they will, what the delay is going to be, but it could also mean that the mission could be scrubbed. But it also had a knock-on effect that there was a share ride probe on there called Janus, JNUS, which really hasn't been designated to what it was actually going to look at, because it all depended upon what date the actual Psyche probe launched. It's a sort of like off the cuff thing. So at the moment, we don't know what's going to happen there. They were due to launch one on Falcon 9 and later this year, and so now everything's been put on hold, unfortunately.
What a shame. Psyche, of course, is this asteroid that has a very, very high metal content and is reckoned to contain, in the value of metals it contains, is more than Earth's whole economy. It's something ridiculous, like $15 quadrillion worth of metals in that asteroid. Everything from tungsten to iron to copper to they thought at first, I think one of the theories still is that it is the actual core of a planetoid that either broke up, leaving the core, or never formed, if you like, a shell around it, a crust around it. And it's an exceedingly interesting object, and the Psyche probe is planned to go and orbit it and have a look at it, because we haven't seen anything like this before. Psyche was discovered back in the 19th century originally. But this is the first chance we've got to go and have a close look at it. So it's a big shame that the software problems with the mission of.
They have done radar surveys of it, so they've mapped it. So they've mapped it quite well.
Yeah.
There is some debate whether or not it's a solid core or whether or not it's just honeycombed. But until we actually get out there and get eyes on it, we won't really know ourselves. So
no, that's right.
But it's going to be an interesting thing when it actually does take off. Absolutely. So yes, there was that. Of course, didn't you have something on Bennu, or somebody had something on Bennu?
Karim, if he's still with us. Karim, you still there? I think Karim's having audio problems at the moment, but he did want to talk about Bennu. So what we'll do, Rachel, what about our viewers gallery for this week? Have we got anything?
Yeah, we've got a good collection. If you want me to go ahead.
Yeah, if you wouldn't mind, thank you. And these are photos that that our viewers have sent in. And if you have got any photos that you would like us to see, that we can look at, then send them to Rachel. I'm sure Rachel's already put her email address in the
I will put the details in the chat again.
Yeah, details in the chat. Send them to Rachel. And we have this weekly viewers gallery. And we're very grateful for your submissions. So keep them coming. And it doesn't matter whether you're just starting off in astrophotography, whether it's your first ever astrophotograph, or whether you're an experienced astrophotographer. We do enjoy looking at them. And we won't laugh, we promise. So do send them in. So what have we got this week, Rachel?
Okay, well, we're going to kick off with a sub-entry by Andy Weller, who I think is again watching tonight. So hi, Andy. And I know Andy really likes taking up he really likes getting in close, on all of those areas that you normally see a wide field of. So I know Andy likes to get in, and he sent us in his Pac-Man Nebula, which is in the constellation Cassiopeia. Nice. He's got his techie details on there, and he said this was an unplanned lucky shot for him. He was just sort of target hopping, and then suddenly came across this and took 10-12 minute images, and the result was better than he expected. So here we go.
Oh, that's wonderful. Well done, Andy. That's amazing.
Yeah,
isn't it?
Lovely.
There's a real sense of depth there, isn't there?
Yeah, you get like that illumination going on behind all of that dark dust.
Yeah. Well done, Andy. That's fantastic.
Yeah, and I really like the color palette as well. So really nice.
So that's 500 frames. Oh, is this from an AVI video? Best 100 frames stacked. So that's remarkable. The Pac-Man Nebula.
Yeah, so that was his information on there. And then we're moving on. We've got another non-resident solar man, Kev, who's sent in another lovely image of the sun. Now, we always joke because I always say I don't like solar, but actually I do think his images are really outstanding.
They are really good, aren't they?
And he said here that the disk luminosity is inverted, which accentuates the surface features a little bit more. And here we go.
And he says he only started in astrophotography this year. So well done, Kev, because you've made incredible progress.
No, I think Kev's been doing it a long time. That might have been a typo. But yeah, so beautiful. Then we've got an entry by Roger.
Who?
Roger who?
Roger
so
who?
He's left his pirate ship and he's gone off to the Lagoon Nebula.
Pirate ship, Lagoon, perfect place for it, really.
And also just to remind viewers as well that Roger and Simon will possibly feature on Sky at Night tonight from 10 o'clock. So if you want to hop over, there might be some solar images that Roger has also taken, so they may get a show as well. So that'll be cool.
Fantastic.
And here we go.
Right, thank you very much. That's great.
Here's Roger's lovely lagoon.
Lovely, Roger.
And then I stuck mine in since we literally took it on Sunday as fresh data. So we did the Eastern Veil Nebula, which is part of the Cygnus Loop region, and we've never done this image before. And we were lucky enough to get given some Optolong filters to try out. So this is the first time we've used the 3 nanometer filters.
Oh wow,
that's lovely.
With the Eastern Veil, and it's still a little bit noisy. We still need a lot more data on it. We only took 2 hours of HA and 1 hour of O3, and we should have probably maybe done it the other way around. But for a first set, it's okay.
And given that the veil is a supernova remnant, isn't it strange how some supernovae go like that? Others just sort of stay in a sort of a circular formation, if you like supernova 1987A, for example. But the Veil Nebula trails right across the sky. It's really strange, isn't it? How you can have the same phenomenon like a supernova, but end up with results that are just so totally different.
It's such a striking area as well, and I went against the usual flow of the side profile face. Obviously, if we'd have rotated it 90 degrees anti-clockwise, you would get that typical Eastern veil, and it sort of looks like, the profile of a face. But I thought I'll try a different rotation and see how it goes.
Well done. That's beautiful, Rachel. Well done indeed. Fantastic.
And so thank you to everybody for sending them in again. They've been really,
yes,
really lovely.
Keep them coming in. We love looking at them.
Week.
We really do. So thank you so much. Okay, so Kevin, as well as your lovely image there, thank you for the feedback on the seeming breakup of our live stream here. It seems to be okay now, you say. So thank goodness for that. I think it seems to be okay. Yes, Daz.
I was just on our little chat about Psych. Andy Weller has put in the chat. He said, if it's valuable, you can be sure that we will go and strip it. The first ship out there should be called Nostromo.
Yeah, that might not be such a good idea, given the precedent for that. But yeah, absolutely. Yeah. Yes, it's worth a lot, that asteroid. It's worth a lot, we reckon. So what I was just going to talk about very briefly, before I do that, Simon, tell us about your spot on the sky at night tonight then.
Oh, yeah. So the sky at night are, how can I put it? They've been very science focused, and the producers had a sort of a thought that perhaps that people actually wanted to see sort of the more peoply side of things rather than just the pure science. So a few months ago, they had a lovely astrophotographer on talking about the photos she was taking. And I'm the next in that series in talking about outreach and mainly doing solar outreach. So we've been doing that at Bath. So we were contacted by the Sky at Night production team and said, well, we're going to be running it this weekend. Would you like to come along? And along came the cameras, and we just ran a normal session. And then they dragged me off to one side to talk about outreach. So unfortunately, you might have to hear me just gabbling on about sort of how excited I am and inspiring people.
Oh, that was really very Brian Cox, that was. How exciting.
So viewers, you've got a choice of viewing tonight. It sounds like a choice
of viewing
now.
Joe's trying to get me knocked off the channel. So I think I think that's the only reason. Sky at Night announced I was on. And so then Joe came, no, I'm going to do a press conference in the White House briefing room. And
so it's Joe or Simon tonight, viewers.
That's the choice. BBC4 or NASA Live. That's your choice.
Yeah. So yes, the Joe Biden's thing tonight is live on NASA TV, which if you want to watch it separately instead of watching it with us, we'd love to have you here watching it with us, of course. But if you do want to watch it separately, just go to NASA TV, or you can just Google NASA TV and you'll go straight there.
Or if you feel more European, you can go to ESA Web.
Oh yes,
TV.
ESA are also
so ESA is also live streaming.
Yeah, the European Space Agency are also live because after all, the James Webb Space Telescope is a product of 3 space agencies: NASA, ESA, and the Canadian Space Agency. I don't know if they're covering it.
I think that's why Kareem's having trouble. He's probably trying to work out the Canadian side of things right now.
There he is.
Speak of the devil, there he is. Yeah. Kareem, you're on mute, by the way, just to warn you before you start talking.
That's because I wasn't sure how my mic is. Is it any better?
Well, you sound a bit like Donald Duck, but that's nothing unusual.
That's my norm.
Yeah, exactly. No, you're fine. Don't worry about that. Did you want to talk to us about asteroid Bennu tonight?
I was just what we were chatting about, I guess, a couple of weeks ago, is this amazing discovery of what the surface of Bennu is really like. And, they liken it to a ball pit because when the sampler set down, there was so much pushed off. And my students and I were going through some of the images the other day, and you can see where every single one of the retro boosters hit the surface because you can actually see additional crater impacts all around that first crater impact. I love the fact that, I mean, it left in December, but we're still getting the chance to analyze the images taken as OSIRIS-REx left Bennu. And this is even before we get the materials. And then Andy and I were chatting, I guess, in Discord about the fact that with Ryugu, when Hayabusa came back and dropped off the samples, now we see so much about the way in which the chemical structure of the surface of Ryugu was different than when we get the meteorites coming through Earth's atmosphere. Yeah. And you can still see the amino acids, but they're still in their primitive form. So there's so much to learn about that evolutionary moment of the creation of the solar system. And it's exciting to know that we have all of these samples on their way back to us. And I'm a flutter waiting for OSIRIS-REx to get back, and the mission's been extended, so when it gets back and drops off its samples, it gets to keep going and do more science.
Yeah, it's going to Apophos, isn't it?
Yeah, Apophos. Yeah.
Yeah.
It's being renamed OSIRIS-REx, Apophos Explorer.
Fantastic.
So because it's dropping off the samples from Bennu next year.
Is it September next year
in Utah? I think it's something like that, Andy. Yeah.
Yeah.
And then it's off to Apophos, which it will reach in 2029. So it's going to be a while. But I don't know if Karim was like me. I was amazed at how fragile really these asteroids are. They're not solid items. They're like just rubble, spoil heaps of rubble.
Yeah.
And as you said, when they tagged it with the sampling arm, it sank in about 2 feet, I think they said it was, and that's why they couldn't shut the lid on it, if you remember. Because
so you might not even be able to walk on it.
Well,
no, because it's not cohesion. It's just gravity holding the bits on. And this is where, like, you start to look at the moons that we were showing during the quiz. You know, you look at Mimas, you look at Pan, you look at some of these moons that have these extraordinary features, and they look solid, but they likely are not. It's likely simply a gravitational tug that's left them there. And so one of the things that my students were asking was, when you look at Phobos and Deimos, and you know that Phobos is being torn apart by Mars because it's within the Roche limit, is it possible that that's actually like Bennu, is if anything actually touched it, it would disintegrate immediately?
Good question. Very good question. Yeah. And these worlds are incredibly interesting and incredibly varied as well. So we're seeing a similarity then between Ryugu and Bennu in terms of their composition, because they're both, as Daz said, more or less rubble piles, aren't they?
They seem to be. Ryugu actually had a bit more of a solid surface from what I remember from Hayabusa too.
Yeah.
And this is also where, when you look at Phobos and you look at Pan, they're close enough to their larger planets that I think if it was just gravity, they would be torn apart already. So there must be cohesion. But then you look at New Horizons having passed by Arrakis, and you know that that's simply gravitational tug that's left it connected with that, cool little snowman shape for the Kepler object that's out there. It's just, we have these objects in the solar system that we know so little about, and we assume based on what they look like from the little pictures that we get. And that's why I'm really excited about, what we'll see with WASP 96b, because we know just from the spectra what we think it looks like. But once we get more IR data, hopefully we'll know more.
Yeah, absolutely. Daz?
Lou's just posted in the chat. Hi, Lou. I hope everything's fine.
Hi, Lou.
It says, be careful here. This is only one sample. Quite possible for an asteroid to be a solid remnant of a failed planet.
Absolutely.
Yeah,
true.
That's put that in
Very
there.
true.
But I know when they did Bennu, I've got to get this right, with OSIRIS-REx, they did do some radar imaging of the inside, and it was quite sort of like honeycombed. It wasn't solid or anything like that. So it's strange. I mean, I can't wait till they come back and analyze it and compare it to Ryugu or whatever you want to call it. I can't remember.
You have to get the Canadian connection. They actually use LiDAR, and that was developed with Canadian robotics and sensors. And that's the same thing that they used for the landing of Perseverance rover on Mars.
Yeah, LiDAR's used. LiDAR's a very interesting device. It can be used for virtually anything. It can even be used to see through foliage for archaeology and things like that, looking for hidden buildings in forests and things like that. So yeah, it's a very interesting thing. And
one thing to harken back to with this idea of what we found with Bennu versus what we were expecting is it kind of reminds me, since we just passed the 50th of Apollo 11 a couple of years ago, when Neil Armstrong stepped down, he had no idea what the ground would be like. And in fact, the landing legs for the lander, which were built here in Montreal, those ones went in a little bit deeper than was expected into the regolith. And so the ladder ended up not going quite as far down as they expected, and so you had to make that hop on that last step. It's, you know, it's the unknown. It's the reason why we want to send the explorers out to all these objects. You know, the Europa Clipper, Dragonfly. We need to explore to really know what these surfaces are like.
yes, because with the Apollo 13, because it was, as you said, it sank. There were actual crush devices on the legs to bring it to designed for it to crush down, but they didn't. So, like they said, they had to do that big hop. And he was still a bit dubious. Apollo 11, sorry. He was a bit dubious. Apollo 13 didn't.
That didn't quite work.
You know something we don't, does?
We didn't go. But with I forgot what was good. Yeah, because when I think it's been said, I don't know whether it's an old wives' tale or anything like that, when Neil Armstrong stepped off the actual foot, he could hear his mother's voice in his back of his head, because he didn't know whether he was going to sink into it or what it was made of, and her voice was saying, if it doesn't feel right, get out of there. So yeah, he had that rope.
How did he manage to fit his mother in that spacesuit as well? That was...
Oh no, they had earwigs.
Ah, right.
So,
I see. Okay. All right then. Moving on. Let me just share my screen. 1 second. Does everybody remember this?
Chelyabinsk.
Chelyabinsk, or whatever.
City in Siberia, 2013. A meteor about the size of a London bus, or let me just work this out. 4.5 giraffes.
I was wondering how many giraffes that would be.
Yeah. Off the top of my head, exploded over the city. Now, this was exceptionally lucky that it didn't hit the city, because it screamed into the atmosphere at some unearthly speed. What it did do, though, is detonate with such an explosion. I think about 5 Hiroshimas worth of energy was dissipated in that explosion. And it did a lot of damage in the city. It blew out a lot of windows. There were 1,500 people injured, because mainly from the flying glass. They were inside buildings and got terribly cut by windows imploding. So it was a really nasty incident. I mean, it was a glorious astronomical phenomenon. However, they managed to retrieve a huge chunk of it from a lake. And that's going to be, probably still is, on display at a local museum. But the interesting thing is, the explosion from the meteor created a dust cloud, which went basically round the planet, and it engirdled the planet. And not long after the meteorite exploded, I think within a couple of days, there was more snow. And scientists found between the old snow and the new snow a thin layer of dust that was quite prominent that they've been able to analyze. And because it stuck out, obviously, as a dark layer between 2 layers of snow. Snow is great for finding things. That's why, you know, if you go to Antarctica and people, you know, walk across Antarctica, because they know meteorites are very easy to spot in Antarctica because they're so dark against the snow. Anyway, I digress, because they've done a new analysis of that dust, and they've found some crystals in the dust that have never been seen in a meteorite before. And let me show you what those crystals look like. And these are very, very tiny. They're sort of, 10 nanometers across and right at the limit of the microscope that was looking at them. But if you look at them, let's go, do you see the one labeled A? I've had to rotate it through 90 degrees to fit it onto the page. But the one labeled A, if you look at the one above that, it's an almost football-like structure. And this is the compound known, the carbon compound known as Buckminster fullerene, and which is a carbon compound that forms these geodesic structures, named after the famous architect Mr. Buckminster, who Kareem will know about this, in Canada, created a dome using this this tessellated pattern, and that everybody marveled at. So it's named after Mr. Buckminster because it's a similar structure. And this one is magnified greatly in the image on the left of the screen. And you notice top right of the screen, we've got more of the same sort of structures, but the one actually labeled A is a different compound. This has a very long chemical name that I'm not going to embarrass myself and everybody here by trying to pronounce. But well, no, not a chance. But I'll give you the chemical formula for it. It's C18H12. So it's a carbon and hydrogen compound that has formed this weird hexagonal crystal. And this goes to show that you can get complex crystals out of something like the Chelyabinsk meteor. And also what they think did this, these actually formed during the explosion of the meteor. It's not something that, they're not something that had been there before. So this explosion created these amazing structures by ramming carbon and hydrogen together and very high temperatures. And I just thought I'd say this because I think these structures are amazing. And as I said, they've never been seen in a meteorite like this before. So this is something completely new. And obviously, they'll be looking for these structures in now they know they're there. They'll be looking for them in other meteorites. The C18H12 crystal, they only found that because when they trained the microscope on the dust, it was right in the middle of the field of view. And they said if it hadn't been in the field of view, they probably would have missed it. So they were very lucky with that. But anyway, I just thought I'd show you that because I think that's really quite interesting. And they'll be looking out for these compounds in these complex carbon compounds like Buckminster fullerene and C18H12 in other meteorites, I'm sure. So there we go.
Yeah, in the chat, Elena, forgive me if I get this wrong, Silapoli is chatting away with our friend Simon, and they're talking about
I've got a friend.
Hey?
I've got a friend.
Yeah, you got a friend in the chat.
Round of applause for Simon.
Yeah, and they're chatting about the 200th William Herschel event that's coming up in Bath later this year. So
right.
That's just a
reminder. But if you two want to go off and get together, don't let us stop you. I mean, no problem at all.
Simon's got a friend. Oh.
Are we all invited to this celebration, Simon?
Oh, everyone's invited. Just come along to Bath. But there's also Slough is holding commemorations as well to the 200th year since William passed away. So the actual day is the 25th of August. So that's the 200th year. Of course, the most important was actually last year when his brother Alexander passed away. That was the 200th year of that. But for some reason, people have forgotten Alexander. Most important engineer, yes. Yeah. Behind great people, there are great engineers.
Absolutely, yeah. Absolutely.
But there's so on the, I think it's the 30th of September, there's a big musical special in Bath, playing all of Herschel's music. So a whole evening of that, and then the following day, you can go to a conference which is all based in Bath, which is all about the Herschel family. And then finally, if you've survived all of that, there's actually a Herschel walk the following day on the Sunday, where the Herschels didn't live in one place in Bath, they lived in several places. So there'll be guided walks taking you around to all the places the Herschels lived and the stories relating to each of those properties around Bath.
Fantastic. Thank you, Simon. Steve, have you got anything to tell us about?
Well, what I could do, if I can share screen, there's just a little sort of photography challenge I was going to just put out there. Something that I
Sounds interesting.
came across. It's very simple. I'll go into. Now, compared to the images you've already seen on screen, this is typical of me. Out of focus, rushed, and all the rest of it. But you can tell it's the Milky Way. And if I just highlight the constellation of Cygnus there, with the North American nebula next to close to Deneb. The thing I'm actually going to point out, because I have noticed this in a number of images, not just mine, is that little trail of stars there, which you can't see visually, but I think photographically, even with quite a short exposure, you get what I call this little trail of wingtip water drops just leading away in this sort of trail of stars. I'd just be interested to know if anybody else has captured the same thing. I don't think it's a sort of a named phenomenon as such, but if I just go back, actually Cygnus, the wings are a bit larger than that, than I've indicated there. So this trail is not actually off the wingtip. Anyway, that's all I was going to throw in there. And the only other bit of information was that apparently at midday on Friday just gone, 95% of the world's population were in daylight or twilight, apparently. There were just some in Australia who were in nighttime, but they reckon that might have been the first time that's happened. I'm not sure why that would be the first time it may have happened, but there you go. Maybe it's just the first time this year.
If you count all the different variations of twilight before you get to total darkness, it's closer to 98%. It's incredible.
Right.
Yeah, I saw the image of that he posted up. That was quite intriguing, actually.
That is intriguing. I wonder why we haven't heard of this before.
It must happen on a regular basis, but obviously not. So something we've missed.
It's not a lot of people suddenly decide to move, is it, or something like that?
Yeah, they're all in one space.
Move into the light.
In fact, Kareem's absolutely right. I'm just reading the piece in the newspaper. It says 99% of the world's population was in sunlight. Or in daylight, I think.
Or in twilight. So part of the problem is if you count the ones in the urban areas in twilight, they can't tell they're in twilight. And that's why you don't necessarily count them and it goes to 98%. But that's because they never actually achieve anything other than civil twilight.
Yeah.
Right, gotcha.
Yeah, it probably boils down to the definition of the various twilights, because there's
the thing that
twilights as well.
The thing that got me is why that doesn't happen on the summer solstice, and it's because on the summer solstice the sun is actually too high up in the north that in the south parts of Australia and New Zealand are then cut out of this swath of daylight. So you have to wait a few days for the sun to come just a little bit further south in its view from Earth for you to get this effect, which is just phenomenal. Like, it really gets you to understand a bit of this geometry of this Earth-Sun system with the tilt and the position in the orbit. It really is phenomenal.
Amazing. And we take it for granted, don't we? We don't even think about these things. And when you think about the orbital mechanics of it, it's mind-blowing. It's absolutely
It's even the same thing with the moon. You know, we're approaching the full moon, but we're not there yet. So we see it in the evening before the sun is set. And yesterday, I just pointed it out to one of my aunts just like that, because I thought, look, it's rising up. It's beautiful. It's this big gibbous. I'll point it out to her. She's like, but the sun's still up. And it had never occurred to her that she sees the moon during the day. And she just paused and she said, wait, does this happen all the time? And my son's like, half the month.
I remember when my sister was at teacher training college. This would have been about 1970, and I remember going outside the house that she shared with some other girls and looking up, and it was a blue sky, and there was the moon. And she said to me, "What's that thing doing there?" And and I said, "Well, it's there for half the month, She said, "I think it's indecent." Never forget that. So I looked at her and I thought, no, I won't pursue that. Steve?
Well, I don't know whether it's just me or whether it's my sort of rhythm of the day, but I think I see the early phases of the moon far more often in daylight than I notice the latter phases in the month, actually. So when the moon is waxing rather than waning, I'm sure I notice it more. Maybe that's just me.
I see. I would say the opposite.
For me, it's early morning when I'm driving into work. I'm driving towards the west, so I actually see the waning moon setting more often. But we'll see if Rachel wants to comment on this. The very first elementary school visit I ever did, I made sure it was a waning gibbous moon so that I would be up in the morning when I was talking to the kids and I would point out the moon to them. And they were all excited that they could see it during the day. And then they went in and they were talking about it in the afternoon. And the principal was like, no, that doesn't happen. No, that was fake. Like there's no way possible you could see the moon during the day. That's ridiculous. I want to know who this person was who came and told you this. Rachel, did you
Yeah, it's quite bad, but I mean, we hear it so often. I think there's even a film, and I'm not sure which film it is, but it's a big named children's film, and at the end it says that like the North Star is the brightest star in the sky, and this is on the film. This is released to the kids,
really?
and I think we need more Kareems coming to our schools.
Absolutely.
I actually encountered somebody quite genuinely who thought that the sun and the moon were the same thing. Just that the sun was there in daytime and the moon was there in nighttime. Unless you know anything different, it's not that illogical, really. But it is, of course, not correct.
True. Michael, have you got anything you want to tell us about Go Space Watch?
Yeah, I have actually. I'll just share my screen. Get that up. There you go. Can you see that?
Yep.
Right. We have on the back of the James Webb announcement tonight and tomorrow. On the 28th of July, we have a talk by Dr. Caroline Harper, who's the head of space science at the UK Space Agency, with a talk entitled "The UK's Role in the James Webb Space Telescope," telling us all about the scientists and astronomers that have been involved in the actual building of the Webb telescope. You may know that a lot of the instruments that are on the James Webb, especially the mirror and the mid-infrared instruments, were designed and built in the UK. So that will be on the Thursday, the 28th of July at 8 p.m. UK time. And tickets are just £3 and can be available at gospacewatch.co.uk.
Great. That looks to be a really interesting lecture. I will try and come along for that one, definitely.
Okay.
Because, the UK, as part of the European Space Agency, has had participation in that.
And I think it's worth, shouting about the amount of work that UK people do in space, in the space industry. We all know about what the Americans do and know what Europeans do in the space industry, and I think we don't really shout about what the UK people do. So I think it's important for that.
Well, a little while ago on Astro Radio, Daz and I did produce a couple of programs about the UK space industry. Perhaps I'll post those on the channel.
Yeah, I'd like to hear those. Yeah.
It is audio only, of course, being a radio program.
Yeah, I'd like to hear those.
But you're absolutely right, Michael. Britain is, has been so involved in the global space industry for so long, but not really blowing its own trumpet.
That's right.
And that needs to change. Mind you, we have got the first. We've got the first launch.
Yes, I'm just about to say that with the first launch from out of Cornwall in September now, I believe, by Virgin Orbit, with a rocket strapped under the wing of the 747, which is taken off from the spaceport Cornwall.
Cosmic Girl, yes, Richard.
Cosmic Girl, that's right, yeah. And Cosmic Girl itself was an original Virgin Atlantic aircraft, and that was its original name as well. So it's quite apt that they use that aircraft to do this work.
Is it named after the Jamiroquai song, I suppose?
I don't know.
Maybe just,
I don't know.
But honestly, guys, tell me, Did you ever thought you would hear the word Spaceport Cornwall in the same sentence?
Cornwall, no.
It's wonderful, and I'm so happy for Cornwall.
I thought it was a Doctor Who fanfic.
Right. You would know, of course. being the huge.
But of course, I was just going to say that, of course, the UK were at the forefront of rocket science, if you like, in the 60s, when we sent rockets out to Australia to launch. But obviously, they're cancelled by the governments in the late 60s. But now we're coming back.
And of course, we were also launching sounding rockets like Skewer.
Yeah.
From Scotland.
That's right. Yeah.
Because they've been pushing this thing about the launch from Virgin satellites this September, isn't it?
Yeah.
And they've been saying, it's the first launch of a rocket from European soil. Well, it's not, of course, because Britain was firing these small rockets like the Skewer back in the 50s and 60s.
Yeah.
From Scotland, and of course Scotland has a new spaceport as well. Spaceport in Scotland.
Yeah. In Shetland.
Shetland. Yeah. So it's
Yeah.
all looking great for UK space, and it's a huge industry. Daz and I were trying to find figures, recent figures for the amount of the money that the UK space industry puts into the British economy. But we couldn't find any recent figures. It was 2016, the last one.
Years ago. And it was an
how much it
astronomical
was?
amount,
Was it 15 billion, something like that? I think?
something like that. It was an
I think it was 15
astronomical
billion.
amount.
Yeah, it's going up daily. But I mean, the amount of jobs that are coming online, especially, and in the next few years as well. I mean, this launch in September. One thing I wanted to say was it's a joint satellite launch between the UK and the US Reconnaissance Office. So it's the UK government and the US government payload on board the rocket. So it's quite high profile. I think there'll be quite a lot of news about it. It'll be all over the news channels when it comes.
God, I'd love to go and watch that. I really, really would.
Same here.
I'm just thinking about the refreshments. The clotted cream scones and the fresh crab sandwiches and the pasty.
Yeah.
Oh my God, the pasties. Oh God, I miss pasties.
Oh God, yeah.
Oh, don't. Mind you, last time I was there, I tried something I never tried before in Cornwall, which was a sweet and sour pasty.
Yeah.
All
right. And of course, the clotted cream.
And of course, the clotted. Oh God, I miss all that.
Yeah.
We don't have these things in Spain, you see. So never mind.
We are supposed to also, towards the end of the year, have vertical launches as well, aren't we?
Yeah,
that's right. That will be from Shetland.
I can't think of the name of the company now. It's not Skyaura were hoping to launch, but of course, they're partially with Ukraine, and so of course they haven't been able to get their pieces. But there was another company. Who's the other company up in Scotland, Andy? Yeah, but they're due to launch hopefully
Orbis.
towards the end of the year. Orbis, that's it.
Yeah.
I kept telling that.
Is Lockheed Martin part of that as well?
Yeah, they hope to be launching.
They've teamed up with the UK.
Yeah,
as well
that's
to
right.
launch rockets as well.
Because from the UK, it's easy to get into a polar orbit.
Yeah, exactly. Yeah,
which is why they're interested. So there we are. Right then, does anybody else have anything urgent they need to tell our viewers about before we?
Well, there's only just talking about Capstone we mentioned last week.
Oh yes, please.
Of course, the Capstone launched from New Zealand about a week or so ago. By Rocket Lab on their Electron rocket, and it put it up into orbit to begin with, and over the next 5 days it fired its thrusters on the Proton part of the stage, and it increased its speed to get the little CubeSat, which is the size of a microwave, up to speed so it could escape the Earth's gravity. It did its final thrust. It released the little CubeSat, and almost immediately they lost contact with it. Luckily, I think it was a case of somebody just had the volume turned down, because they were able to restore it within 24 hours. So everything's looking good.
Everything's looking
of
good
course,
for
this CubeSat now is going to fire its own little thrusters and its rockets to give it a little bit of a boost and to set it up correctly. But it's going to completely shoot past the moon. And then it's going to, let me just see, it's going to scroll down. It's going to 1.3 million kilometers, which is 810,000 miles away from Earth. And then what will happen is it will slow down, and the gravitational pull of the sun, moon, Venus, Mercury, and all that will slowly pull it back towards the moon. And it will then go into this near rectilinear halo orbit, which is, as we said before, is the orbit that's the gateway is supposed to, of the Artemis program, is supposed to go into. It's a very elliptical orbit, but it's going to be sending back details it says it will also demonstrate innovative navigation solutions, including spacecraft to spacecraft navigation, and one-way ranging capabilities with Earth and ground stations. So it'll be using positioning on the Earth to actually position it, give us an exact position of where it is. Yes, Simon.
They uploaded a DUF data package to Capstone just after launch, and it took 2 days for the reset mechanism to clean the spacecraft down, go back to its ordinary programming, and it's self-righted. So it's an engineer killed it, but luckily someone had thought, let's protect it against engineers, and it reset itself.
Always a wise move.
Yeah, always a wise move. And just before we actually go and have a shutdown, just before we come back at 10 o'clock for the big announcement, can I just mention Radio Super Green? Now, as you all know, that we originally formed on Astro Radio Earth, this panel, and we resurrected ourselves onto YouTube. Well, it was also a music station, and the music side of the presenters have got together and they've created a radio station called Radio Super Green. If you search it on the internet or on Facebook, and then just join the link. At the moment, they're very small. They only, I think it's Tuesday night, Thursday night, and Friday night. So there will be more dates coming on. But it's very eclectic music. They're all types of music, some of the music from all around the world. But I wish them all the luck, and I'll definitely be listening. I just want to put that in there
too. So
yeah, so good luck to you all.
Green. Absolutely.
Yeah, Radio Super Green. Just tap it into your searcher, and then you'll be able to find them. They're absolutely fantastic. A good bunch of people, actually.
Okay. So thank you, panel. We will return in about 50 minutes at 9:50 p.m. UK time to share with you Joe Biden's presidential briefing from the White House, the release of the first James Webb Space Telescope science image, which is a deep field image, a deep field infrared view of the universe. We are all very, very excited to see this, and we hope you will join us back here in about 50 minutes. That'll give us time to all go and have a cup of coffee and put some lard on the cat's boil and all that sort of stuff. So thank you very much for joining us so far. We hope you can join us later at 9:50 UK time. Thank you so much to those who submitted their images for the viewers gallery. Again, thank you all for your support. Please don't forget to subscribe, hit the like button. We would love to get more subscribers to enable us to do the things we really want to do with this channel. So please, if you haven't subscribed, we would really appreciate it if you could, and tell everybody you know about it. Yes, Daz?
Just one thing. Somebody's saying, Cornish pasties and clotted cream. Why are you living in Spain?
That is a very good question. I have to say that Spanish food is absolutely unbelievable, and I love it very much. But of course, being English, I do miss Cornish pasties and clotted cream and all.
That was Sal Sativa.
Sal, yeah, I know. I've been here 20 years, and every friend that comes over here, I have to give them a shopping list, because it's funny the things that you really miss and you don't think you'd really miss them. For example, Heinz salad cream, I miss.
I'll bring you some over, mate.
Oh, thank you, Ray. When you come over, Daz, bring me some, because
and some HP sauce.
We can't get that here. Mayonnaise, obviously, which is the Spanish one, but no salad cream. I'm also partial to Heinz sandwich spread, which I love in the summer.
Oh,
yeah, and you can't get that here either. So I'm not being sponsored by Heinz. Don't worry. Heinz tomato soup I love as well, which
I've only got one case. Just a quick one,
Derek.
You
don't have to bring more than one case when you come in October, Daz.
Derek,
all right then. All right,
Derek, sorry, just a quick one, Andy. Derek has said Capstone is shiny. Would it be possible to see it orbiting the moon? No.
The size of a microwave oven, definitely not, Derek. No,
unless you got the
not.
Hubble.
No, there was something I was going to say then, but I've forgotten what it was.
Oh, sorry, I'm sorry.
So there you are. All right then. Hope to see you all back here now. Thank you so much for your support, viewers. We do appreciate it. Hope you've enjoyed the show so far, and we're really looking forward to 10 o'clock UK time. It's going to be amazing. Trust me, I'm a doctor. Right. Okay. Take care, guys, and we will see you soon. Guys on the panel, can I just ask you to mute your microphones until 9:50, if you won't mind?
Somebody's commented on Simon's T-shirt. What's on Simon's T-shirt? All I can see is
It's
Simon.
a great T-shirt. It's all about equations.
Oh, excellent. And then there was like 11.
Right, we'll say goodbye then, guys.
Cheers, see you in a while.
Bye. Thank you.
I won't be able to stay for the second part today.
Hello. Is there anybody out there?
So we're taking a break until 9:50. We're going back to the in 50 minutes. I'm going to grab a coffee. Are you all right here, Danny? Oh, I just Well, welcome back, viewers. Thank you for joining us for the second part of today's show, where we're awaiting the release of the first science image from the James Webb Space Telescope in a White House press briefing given by US President Joe Biden. And the image will be a deep field infrared view of the universe, which we're waiting for with bated breath, because we're expecting something truly amazing. It's worth pointing out that the Webb has only been observing fully for 9 days, and there really hasn't been enough time to carry out the necessary integration time for long exposure images. So what we're going to see may not represent the full power of the Webb telescope, but it'll be a taster, if you like, but it should still be pretty amazing, whatever it is. So Daz and Michael, I see you're back. How are you guys since I last saw you?
Oh, we're fine. Thank you very much. Well, I am. Anyway, it's Steve as well. Steve's joined us.
Coffeed up and ready. Hi, Rachel.
Yeah, we're all waiting for this. I'm just trying to.
So thanks, viewers, for joining us. We have no idea what format this briefing is going to take. We don't know whether they're going to proceed the unveiling, if you like, of the image with the program about the Webb. We hope that Joe Biden will get on to showing us the image fairly soon, but we'll have to suck it and see, because we're as much in the dark as you are, viewers, about what exactly is going to happen. So I have got NASA TV running in the background here, and I'm just going to just give me a second to sort this out. And I'll sort that out now. Just give me a second. By the way, something in the news that I did forget to mention earlier was that today NASA launched the third of 3 sounding rockets from Australia, from the Northern Territories in Australia, where the Australians have built a spaceport, if you like. And the launch went off perfectly. And this launch was to because it's a sounding rocket, it basically doesn't go into orbit around the Earth. It goes up and comes down. But while it's up, it was acquiring images of Alpha Centauri A and Alpha Centauri B in the far ultraviolet wavelength. So that will be interesting to see those images, what Alpha Centauri A and B look like in the far ultraviolet. So just give me 1 second, and I'm going to sort this out.
There was oh, he's gone.
Well, that's working.
Yeah, I got a funny feeling they've changed the time.
Why is that?
There was something that popped in the end of our chat on the previous show earlier, and it said that mentioned 11 o'clock. And I think something, I think Rachel's just popped up something.
10:30.
Yeah, I think Kev, who's watching the stream or whatever it is, has just said they've said it'll now start at 10:30.
10:30, right? Okay.
Oh, we'll have to do some mime or something like that to keep people entertained.
Well, it's certainly not there at the moment.
Right, we're coming off that.
Where did you see that, Rachel?
Kev said NASA TV has announced that the briefing will start at 10:30.
Right. Okay.
Didn't clear that through us.
Well, in which case, why don't we leave the viewers to look at NASA TV, and we can come back a bit later. What do you think, guys?
Yeah, what are they showing on there? Which one is it? Public or media, Andy?
Public.
Public, right. So let's go public. And what have we got? Oh, we got an aeroplane.
We got drones.
I wouldn't say he's a drone. He's a big chap.
Steady. CIA listening. Okay. Well,
Yeah,
what we'll do then, we'll come back at what, 10:20, guys?
That's good.
Yeah, that'll be good, and then we'll do it then. And
okay. And
I mean,
in the
if
meantime, I'll switch the volume on, and we'll leave the viewers with NASA TV.
Yeah.
Okay, we'll see you back here at because the broadcast has been delayed a little bit. We will see you back here at 10:20 UK time, viewers. And in the meantime, I will leave you with NASA TV.
Yeah, I think Joe's got to have his tea before he can.
Oh yes, of course he has.
Yeah, have
and
tea.
his pills. So. Okay, we'll see you in a bit, viewers, and thank you for staying with us.
Houston, please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
We hear you loud and clear. How about us?
We hear you loud and clear. Please stand by for opening remarks.
Hi, my name is Dr. Deborah Taylor Long, and I am board chairwoman for the Gifford Youth Achievement Center, also known as GYAC. We are grateful for this extraordinary opportunity to speak with astronauts at the International Space Station. Now, here's our first question.
Hi, my name is Ada Robinson. My question is, what type of food do you eat while in space?
Hey, that's a great question, and it's one of the unique things that we have to get used to while we're up here, because our food has to be packaged differently than it is on the ground. As a matter of fact, right here I have it's a container of pasta and turkey in here, so kind of like a spaghetti noodle type of thing. And so you can see it is, Jessica's going to bring it up to the camera, but it is hard. It's had all the water moved out of it. And so if she knocks on it, it's hard like a brick. And then what we have to do is we go up to a special machine that injects water into the straw end of it. And then we mix it up and we let it sit for a few minutes, and then it's just like eating it back home. But all of our food has to be contained in little bags like this. Otherwise, it starts floating away and it's hard to control. So no plates for us up here. Just eating out of bags, and really the only utensil we use is a spoon. So we carry around a spoon and then bags of food.
Hi, my name is Chancellor Braceley. My question is, can you hear any sounds in space?
Yeah, so it's a good question, and certainly when we're up here on the International Space Station, we hear lots of sounds. It's actually quite noisy on the ISS with all of the different machines running, all of the science experiments that are going on. It all kind of creates a pretty loud background noise that we kind of hear all the time, but we can kind of tune that out so that we can hear the other sound that we hear a lot of, which is the ground. So we have speakers in each one of the modules on the ISS, and that is how we talk to the ground teams that help tell us what to do and where to find the things we're looking for. So we're super grateful for the huge team of people that help keep ISS operating.
Hi, my name is Christian Gashland, and my question is, how do you sleep in the space station?
Sleeping in the space station took a lot of getting used to, at least for me. So we have sleeping bags. They're blue sleeping bags, and we have a small little crew quarters that's like a little closet, like you can see on the screen here. And the sleeping bag has little armholes in it, and we can tuck ourselves in there. And some of us like to free float inside our crew quarters, and others strap it to the wall so that we're kind of secured in one spot there. But it's pretty cozy, keeps you pretty warm, and after a couple weeks of getting used to it, you can sleep really, really well.
Hi, my name is Adriana Cortez. My question is, how do plants grow in space?
Well, that's a great question, and it is something that we're spending a lot of our time and energy on right now. Once, as NASA starts to pivot towards going to the moon and eventually to Mars, plants and growing plants is going to be a big part of that capability to provide not only food but be part of the life support system, producing oxygen. We are doing an experiment right now just behind the camera called X-Roots, which is experimenting on different ways to provide water to plants. As you know, there's no gravity in space, and so you can't just pour water on the plants. And we've learned that plants don't necessarily need gravity to know which way to grow, but they do grow their roots towards the water supply. And last year we grew some chili peppers, which apparently were really, really hot. We've had some of our colleagues that got to taste test those things. Jessica and I and the rest of our crew have gotten to grow some lettuce and some radishes over the last few days. And it's really exciting to see those things. We got other living organisms up here, so it's really fun to be able to take care of those and watch those things grow and practice getting our green thumb.
Hi, my name is Caleb Baker. My question is, what equipment do you use to breathe in space?
So inside the International Space Station, we have an environment where we have just the right amount of oxygen and nitrogen for us to breathe. So inside the ISS, we have a very Earth-like environment. Of course, outside the ISS, out in space, it's a very different story. And so when we go out on our spacewalks or our extravehicular activities, we have our spacesuits that we wear, the big white puffy suits, and the backpack on the back of those suits contains the life support system for us, which basically means it contains the oxygen that we have to breathe, as well as the mechanism for scrubbing out the CO2 that we breathe to enable us to have the right amount of environment and air to breathe while we're out on the spacewalk. So there's enough in there for us to be outside for around 7 hours or so to get a lot of work done while we're out there.
Hi, my name is Jasmine Harris. My question is, how do you drink water in space?
That is a great question, and it's one of the things that we can have the most fun with up here, because water behaves very differently in space. Instead of going to the bottom of a container, it'll just float inside the container. And so a typical water bottle doesn't work quite as well up here, because it's hard to get the air away from the part that you want to drink water out of. You can spin it and it'll separate, and so the water tends to go to both sides of it. But water bottles are kind of difficult. So what we have mostly up here are drink pouches, and so we get a whole bunch of these. Sometimes they're juice. We have coffee and different things like that. This one is just water, and we put a straw into it. We put it into we plug it into the same machine that we do the food, and it fills it up with water, and then we can squirt our water out like so. And so it's kind of fun. You can get these bubbles that are just floating around up here, and play with them. But they can also make a big mess. But it's really unique. You can see the water just forms a perfect sphere up here, and will float around until we drink it.
Hi, my name is Kendall Melton. My question is, how was the docking at the space station?
Yeah, it was really neat getting to dock to the space station. As we were coming in on our SpaceX Crew Dragon, which we've named Freedom, as we were approaching the ISS, it was really neat to see the ISS in the blackness of space, just nothing out there, and the ISS appeared as a super, super small gold kind of imprint on the back of the night sky. And to know that that was our destination, that was going to be our home for the next several months, to be able to kind of see it appear a little bit out of nowhere was just amazing. And then to, of course, get closer and closer to it and slowly approach and then have a successful dock was just awesome. And then to get to come onto space station and greet all of our friends from Crew 3 and Expedition 66 and 67. It was just an awesome memory to be able to embrace them when we arrived.
Hi, my name is Kaylin Pound, and my question is, why do astronauts train underwater?
Well, that's a good question. We train in the water and underwater specifically to get as close as we can to simulate weightlessness, especially for long periods of time. So to practice for spacewalking, we have a gigantic swimming pool that has a full-size mock-up of the International Space Station in it, and we get in the spacesuits, and we go down there, and we'll be in those suits for 6.5 or 7 hours for each training event. And the divers that are out there assisting us help us get weighed out so that we're neutrally buoyant, so we don't float to the top and we don't sink to the bottom. And that simulates weightlessness as close as we can get on Earth, and it allows us to practice all the intricate tasks and teamwork that we have to do when we go out the door for a spacewalk.
Hi, my name is Landon Cheney, and my question to you is, how is food delivered to the space station?
We are super lucky up here that we have cargo vehicles, so spacecraft that come up and deliver supplies and hardware, science, and also food. And so the next one coming up will be SpaceX Dragon 25. That will be coming up in the next couple of weeks here, bringing lots of things, including food. So we are super grateful for that opportunity and that capability to bring us food. And in addition to kind of our standard menu of food, like the turkey that Bob was showing you earlier, sometimes these cargo vehicles also bring us treats. Sometimes they are allowed to load at the last minute some fresh foods, so some things like fruits or even ice cream that we might, hopefully, we've got our fingers crossed, that we might be able to get some on our next cargo vehicle.
Hi, my name is Ria Coco. My question is, what are the job duties you have in space?
Well, one of the really fun things about being up here is that no day is the same. We take part in so many different tasks and perform so many different science experiments that there's just so many different things to do. Some of it is maintaining the space station and fixing things. The space station is, little over 20 years old now. So just like a 20-year-old house, it has things that need taken care of and modernized and repaired. And so we do things like that. And then also upgrading things and making and installing new software and new hardware on the space station. And then, of course, at any given time, there can be 250 to 300 different experiments on board. And so we end up being the people that run those experiments, and sometimes we're taking part in those experiments ourselves as part of the human research program. So we take part in different things that look at how the human body responds to being in space for an extended period of time. So any given day, we can be a repair technician, we can be a scientist, you name it. And we touch all different forms of science out there, from materials science and developing new ways to form different materials, all the way to medical science and geology as well. So the opportunities are endless. There's just so many different things that we get to do up here.
Hi, my name is Jamal Ralston. My question is, how hard is it to move around inside the space station?
So if you were to ask us that question when we first got here, the first week or so, our answer would definitely be that it is pretty tough. But with time, just like with anything, we have definitely adapted and learned how to use all 3 different planes, the whole volume, and learned how to float effectively. So we use all of these handrails that you can maybe see to kind of hook our feet onto, as well as our hands, and kind of Spider-Man our way through station. So it's super fun to learn how to move in microgravity.
Hello, my name is Lenore Carter. My question is, when you're exiting the Earth's atmosphere, do you feel heat?
That's a good question. On the way uphill during launch, we don't really feel too much heat, and part of that is because our vehicle is starting out very slow and gradually accelerating as we get higher and higher. Plus, we have the vehicle around us. So in our seats, we have very good air conditioning. We're protected by our suits, and so we get to just enjoy the ride and the incredible acceleration that the rocket provides. And it was just such an amazing experience, feeling the rumble and the thrust and the acceleration as you're getting pushed back into the seat was just absolutely phenomenal. And then at an instant, the engines shut off, and you go from feeling 5 Gs of force on your body to instantly being weightless, and it was absolutely spectacular. We'll let you know in a couple months on our way home whether we feel
Okay, welcome back. Hope you're still with us, viewers. And if you are, thank you for staying with us for this long. Very exciting night. I see my fellow panelists are off getting coffee and whatever. So tonight really is the culmination of many, many years of development, launch and calibration of the James Webb Space Telescope. So it really is an important night. And of course, the fact that the President of the United States is giving this press briefing is a measure of how important this night is seen. The James Webb Space Telescope, of course, being a product of 3 space agencies: NASA, the European Space Agency, of which Britain has had a part, and Michael with Go Space Watch, your lecture about Britain's role in the James Webb Space Telescope on the 28th looks like an important lecture to watch. So hope we can go to Go Space Watch for that, and I'm sure Michael will post the details or tell us the details again before the end of this program, just to remind people. And welcome back, Steve. You okay? You excited?
Yes, good, thank you. Yeah, I was pondering just now actually that there was so much complexity in James Webb in the build-up and so much delay that I was really trepidant as to whether it was going to work properly at all or whether there'd be glitches. But it's just been phenomenal every step of the way, right from the launch. It seems to have gone perfectly, and it's a credit to everybody who's involved in the launch team and previously and in the science team to get all this together. It's just a phenomenal achievement, I think.
And if you are a member of the James Webb Space Telescope group on Facebook, which I am, many people there have actually worked on the telescope, and the overwhelming sense of pride that you get for those people about what they've accomplished, well deserved, of course, is really touching, because this is a human story. Apart from anything else, this is not just hardware. This is the story of humans coming together around the globe to create something truly momentous, and something that is already in the history books. And I'm sure all of us will remember this night for a very long time indeed.
And you're going to say a bit more on that as well. The fact that the UK or the European consortium, which the UK has a lead role in that, built the mid-infrared instruments on Webb, and they actually completed it and delivered it to NASA, believe it or not, in 2012.
Really?
Yeah.
Absolutely. It's actually 10 years old.
Amazing.
You can't believe it. We did our bit, okay.
Yeah, because ours, the MIRI, it was one of the last things to be started, as Michael said, by a group of English companies and agencies, and it was one of the first to be delivered. It's been sat on the shelf. Of course, this is the instrument that we've been waiting to cool down to below 4 Kelvin.
Yeah.
Because isn't the ambient temperature of space about 7 Kelvin or something like that? I could be wrong, like but this had to be cooled down to below 4 Kelvin, and they achieved it about 10 days ago, and they managed, I think it's 3.4. Because all these instruments, all the rest of the instruments are all passively cooled, but the MIRI had to have a sort of like a refrigeration unit pumping nitrogen around.
If you're wondering why these instruments have to be so cold, it's because it's an infrared telescope. And infrared radiation basically means heat. So if you've got an infrared telescope, the last thing you want to detect is the heat from the telescope itself. And to trap these infrared photons that have been traveling perhaps for billions of years across the universe, you need a detector that is not detecting anything else, because there aren't that many photons. So they need to capture every single possible photon. And that means cooling the telescope right down to within a few degrees of absolute zero, basically, to trap the photons and not trap any other source of heat, for example, the telescope and its instruments. So this is why they have to be cooled down to such a ridiculously low temperature.
Yeah.
And one of the engineers who actually built the Mirror, who's actually retired now, he's not far away from you, Daz. He lives in Shropshire, John Thatcher.
John, yeah, that's it. He lives in Shrewsbury.
Yeah.
And luckily we had the privilege to talk to John a year or so back on Astro Radio Earth, and a very interesting chap.
Yeah.
He by time, I mean, he was retired before the thing even launched.
Yeah.
But he was a very interesting guy. Not only was he quite forward, he sort of like dissed us quite a bit of dirt about NASA. So it was a really fun night. It was full of laughs, full of giggles, lovely bloke. And yes, as you said, he just lives down the road in Shrewsbury, just from me. So, on
now,
the Welsh
panel,
border.
can I ask one of you to do one thing? When the image is displayed, which presumably will be full screen, can one of you do a screen grab of it?
Will do. Yes, will do.
Because I can't do that because I've got it running on another monitor and I can't grab the screen from that one. So if somebody could grab an image of it, and then you know we can perhaps just briefly talk about it after Joe Biden's briefing. We have no idea how long the briefing is going to last. We hope that the image will be fairly upfront in the briefing. So we'll just have to wait and see. And it's now about 2 minutes away.
I have my sticking tool ready.
Oh, fantastic! Well done, Michael. I knew we could rely on you and your tool. So,
are you going to put the stream on our screens, Andy?
Yes,
moment,
I am.
All I've got is our gallery. Yeah.
Yes, absolutely. I'm going to turn the sound on as well. I don't know how the mix is going to go with our voices and the sound, so I suggest we don't actually talk over it. We let Joe Biden say whatever he's got to say. I'm sure the viewers would rather hear him than us.
I mean, I don't know if anybody else experienced it, but while we were looking, you left the stream running. I did find that there was a lag on there. I don't know whether it's just bandwidth or whatever.
Was it actually? Was it actually jerky?
Yeah,
it was.
Right. Yeah.
Okay.
Yeah, beef jerky. I mean, I don't know if anybody else saw it, because they had loads of children asking astronauts on the International Space Station, but it was sort of like stuttering and or out of sync and things like that. So I don't know whether it may happen again when we go live to this. We'll see, because it's the same when we play the introduction to our normal show. We get a bit of a lag on there, but obviously other people have experienced different problems.
Well, my daughter Chloe, who's in the other room, actually timed the lag tonight, and it was 17.5 seconds.
Yeah.
So, yeah, and can we just say hello to Chloe? I noticed she popped up in the chat earlier. Say hi to Chloe.
Chloe.
Hi, Chloe. I would get her to come on camera, but she's a little bit shy about doing that, as we know. So you're very welcome, Chloe, darling, and I hope you're watching, and I hope you enjoy the show. Okay, it's just about to start. So what I'm going to do now, we're going to go over back to NASA TV. I'll turn the sound on, and we'll just wait and see what Joe Biden's got to say. This should be good. So here we go, and let's. If it looks like it's dragging on after the image has been displayed and there's nothing much useful being said, we'll come back here and then talk about it. Does that sound like a plan?
Yeah, that's fine.
All right then. Great. Welcome back, Rachel.
And Roger. Oh, Roger's gone again.
And can I just say, viewers, before the presentation starts, if there is any stuttering or jerkiness in the video, we do apologize, but we're doing our best to bring it to you, and we honestly don't know what's going to happen. So apologies in advance if the video is a bit jerky. But as I said, if it is, you can watch it live on NASA TV on the web. Just Google NASA TV and you'll find it instantly. And you need to go to the public channel there. And well, let's wait and see what happens. You're watching Space Oddities. We're just waiting for this really, really annoying music not to loop round again, and we're waiting for the President of the United States. So in the meantime, we'll leave you with some nice elevator music. And apologies again if the video stream that we're relaying from NASA TV is a bit jerky or otherwise not working very well. Of course, as I said, you can watch the thing live on NASA TV. Just go to your browser, Google NASA TV, and it's the first hit, and go to the public channel. So we'll just wait for Joe then. And just to remind the viewers, if you haven't hit the subscribe button for our channel yet, we'd be very, very, very grateful if you could do that. And click the like button for the video, if you like it, of course. Don't bother. But we'd love you to subscribe. We're here every Monday evening. And we've got the special program tomorrow. And no, there goes the music again. We've got a special program tomorrow evening at 8 p.m. UK time, when we'll be talking about the other images from the James Webb that are being released tomorrow. So look forward to that, and the live stream is there, so you can set the notification bell for it to be reminded, just in case you forget, which I'm sure you won't. But in the meantime, let's return to that music. You're watching Space Oddities, where we're just waiting for the President of the United States to present the first science image from the James Webb Space Telescope. It says on the screen it's going to begin momentarily, which to me means it's going to start and then immediately finish again. But anyway, that's how it is. So, well, I'm not going to apologise for the delay because there's nothing we can do about it. So thank you for bearing with us, and well, we'll just have to wait and see what happens. You're watching Space Oddities. We're just waiting for the President of the United States. What a situation to be in. Incidentally, viewers, it is our intent on the channel to bring you major space events like this live. So I don't think I could go through this again. No. But that's what we'd like to do. We'd like to bring you these sort of important events, important space launches, important things in astronomy. Is it going to start again? Yep. We'd like to do that, so bear with us, and we'll get that organised, because there's lots coming up over the next year or so. So stay with Space Oddities, and we'll bring you all the very best in space and astronomy. And thank you. I'm just hoping we don't suddenly hear the president has left the building.
You
You're watching Space Oddities. We are currently awaiting the President of the United States. I can't tell you anything more. Thank you for staying with us. You're watching Space Oddities. Thank you very much for staying with us, viewers. We know as much as you. We are waiting for the President of the United States to get his act together. I wonder why there's such a delay, because it's now, what, an hour and a quarter past the original scheduled time. I wonder what's gone wrong. Well, I've just had a notification that YouTube has detected copyrighted audio in this stream, which presumably is that awful music. So I'm going to shut the music off so that we don't incur the wrath of YouTube. Please bear with us. Thank you for your patience, viewers. We now hand you over to, well, she's definitely not the president, quite obviously, not unless something's happened we don't know about. But thank you for staying with us.
Good afternoon, Mr. President, Madam Vice President, everyone. Thank you for joining us. This is an historic occasion. We are here to view the highest resolution image of the infrared universe anyone has ever seen, captured by the most powerful telescope anyone has ever made. I am proud to turn things over to a president and a vice president who have charged the entire Biden-Harris administration with leading with the science and who believe deeply in the power and possibilities of science and technology for all of us. Madam Vice President, we particularly appreciate your leadership of the National Space Council and your commitment to ensuring innovation in space. The floor is yours.
Thank you. Thank you. Well, good evening, everyone. I am very honored to be with you all. President Joe Biden and I talk often about our mutual passion for everything you all do. This is a very exciting moment to join you for the unveiling of the work that you have been laboring on for decades. So to our President Joe Biden, thank you for your leadership around all of these issues. Our NASA Administrator Bill Nelson and the Office of Science and Technology Policy Acting Director Dr. Alondra Nelson. Thank you also to our colleagues from across the White House and NASA and everyone else joining us from home. So yes, as chair of the National Space Council, I know that today represents an exciting new chapter in the exploration of our universe. From the beginning of history, humans have looked up to the night sky with wonder. And thanks to dedicated people who have been working for decades in engineering and on scientific marvels, we can look to the sky with new understanding. When NASA launched the Hubble Space Telescope in 1990, we were able to see the stars unobstructed by the Earth's atmosphere and understand the universe in ways we could have never imagined even a few decades earlier. And now we enter a new phase of scientific discovery. Building on the legacy of Hubble, the James Webb Space Telescope allows us to see deeper into space than ever before and in stunning clarity. It will enhance what we know about the origins of our universe, our solar system, and possibly life itself. This was made possible by partnership among nations, and it is an example of how the scientific endeavor can build upon the international rules and norms that govern our cooperation in space. This telescope is one of humanity's great engineering achievements. And the images we will see today are a testament to the amazing work done by the thousands of workers across our nation who dedicated years to this project. They embarked on this complex endeavor for the benefit of humankind, and in the process accelerated American innovation, strengthened partnerships with our allies, and will undoubtedly inspire generations to look to the heavens with excitement and ambition. With that, it is my great honor to introduce a leader who has always believed in the power of American innovation and international cooperation to achieve the remarkable, our president, the President of the United States, Joe Biden.
Well, it's great to be with you all. And I was going to say good afternoon, but we're starting this meeting late because I was engaged in preparing for a trip to the Middle East. But today is a historic day. And thank you, Vice President Harris, Chair of the National Space Council. And thank you, my dear friend and our outstanding NASA Administrator, and the only guy here that's been in space, Bill Nelson. Bill, you're a good friend. Thank you very much for what you're doing. And Dr. Nelson, you're doing a great job leading this Office of Science and Technology and Policy. It really is a matter. It really is amazing. 6.5 months ago, a rocket launched from Earth, carrying the world's newest, most powerful deep space telescope on a journey 1 million miles into the cosmos. First of all, that blows my mind. 1 million miles into the cosmos. Along the way, unfolding itself, deploying a mirror 21 feet wide, a sun for science and technology, for astronomy and space exploration, for America and all of humanity. You know, as an international collaboration, this telescope embodies how America leads the world, not by the example of our power, but the power of our example. A partnership with others. It symbolizes the relentless spirit of American ingenuity. And it shows what we can achieve, what more we can discover, not just about distant places, but about our very own planet and climate, like NASA's Earth Systems Observatory that we launched last year. That's why the federal government must invest in science and technology more than we have in the past. These images are going to remind the world that America can do big things. And they remind the American people, especially our children, that there's nothing beyond our capacity, nothing beyond our capacity. We can see possibilities no one has ever seen before. We can go places no one has ever gone before. You know, you've heard me say over and over again, America is defined by one single word: possibilities. Possibilities. I want to thank the team at NASA for once again showing that that's who we are. That's who we are as a nation of possibilities. And now let's take a look at the very first image from this miraculous telescope. NASA Administrator Nelson, I'm going to turn this over to you. So will you please tell us about what we're seeing?
Mr. President, if you held a grain of sand on the tip of your finger at arm's length, that is the part of the universe that you're seeing, just one little speck of the universe. And what you're seeing there are galaxies. You're seeing galaxies that are shining around other galaxies whose light has been bent. And you're seeing just a small little portion of the universe. You know, 100 years ago, Mr. President, Madam Vice President, 100 years ago, we thought there was only one galaxy. Now, the number is unlimited. And in our galaxy, we have billions of stars or suns. And there are billions of galaxies with billions of stars and suns. And we're getting our first glimpse. As you said, Mr. President, we're looking back more than 13 billion years. Light travels at 186,000 miles per second. And that light that you are seeing on one of those little specks has been traveling for over 13 billion years. And by the way, we're going back further because this is just the first image. They're going back about 13.5 billion years. And since we know the universe is 13.8 billion years old, we're going back almost to the beginning. That is the discovery that we are making with this. There's another thing that you're going to find with this telescope. It is going to be so precise, you're going to see whether or not planets, because of the chemical composition that we can determine with this telescope of their atmosphere, if those planets are habitable. And when you look at something as big as this is, we are going to be able to answer questions that we don't even know what the questions are yet. This is what's happening. And it's because of this wonderful team that's out here. Part of that team, led by Thomas Zurbuchen, it was in trouble financially 5 years ago. He took it over. He got Greg Robinson, that you're going to meet, to direct it, and the result is what you've seen. So what an incredible team, joined, by the way, with our international partners, the European Space Agency and the Canadian Space Agency. So this is an international endeavor.
It's amazing. I wonder what the press like in those other places.
We're going to give time for the press to leave, and then we'll continue the briefing.
Well, that would appear to be that. Any thoughts, anybody? First thoughts?
I think they could have given us a bit of a better review. It's, to be quite honest, not. Unfortunately, the image doesn't look that brilliant for me. What's on there is brilliant, but it appears that YouTube hasn't done it justice. So we'll have to wait until we actually see some close-up views of it. I mean, I don't know why we've got to see these people down the left-hand side. And that we could have had a bigger image, but yes,
they could have at least showed it full screen.
Yeah,
exactly. I mean, it's like you say, there's lots of lensing going on there. There's lots of
a lot
colors.
of lensing going on there. Did you see the Einstein arcs?
Yeah, exactly.
Amazing.
Yeah,
absolutely.
Well, hopefully they'll show that in better resolution tomorrow with the other pictures, so we'll have a better chance of studying that.
Yeah,
But so I mean,
how many galaxies there were actually in that image that they detected? They didn't say anything like that, and how many more there is in there than they've seen previously.
yeah, I mean, I would think every dot in there is a galaxy, except for the foreground stars.
Yeah.
So yeah, that does. It's an impressive image.
They didn't actually zoom into the picture, did they?
No, this is the picture I'm looking at here is the one where they did expand it, but you've got people on the left-hand side who look really miserable, and things. But yeah, I mean, I think really what we've got to do is actually look at what we're actually seeing. Like you say, the lensing is absolutely incredible all over the place.
Absolutely. They really could have done that a lot better, in my opinion. And what was that at the end? We'll just let the press leave and we'll continue with the briefing, and then
then it all
I
disappears.
didn't understand that at all.
No,
Yeah, probably their Zoom ran out.
Yeah.
So
anyway, well, listen.
I got the basic version of Zoom. That's pretty nice.
Yeah. We'd like to thank you, viewers, for sticking with us, and apologies for the huge delay while Joe packed his suitcase for the Middle East. Anyway, an amazing image. Do join us tomorrow evening when we'll be examining that image and the ones that are being released tomorrow. So thank you so much for being with us. We do appreciate you being here, and we will hopefully see you tomorrow. And would like to thank you. And don't forget, if you haven't hit the subscribe button yet, just a final reminder this evening to do that, because we do appreciate it. Thank you so much. Thank you for your contributions to the viewers gallery. And Rachel has put her email address in the chat. Please do send your images to us so that we can have a look at them, because we do enjoy looking at them.
Thank you for being patient and bearing with us. There was some great chat going on in the actual chat room. So yes, thank you for that. I was actually watching another live stream where I had to switch off because the language was getting a bit ripe. So they were getting a bit angst, and that was actually from Americans. So and they're living it. We're in the middle of the night here. So yes, thank you very much, everybody.
You've been fantastic. We do appreciate it.
Yeah.
We will be back tomorrow evening at 8 p.m. UK time to look at the that image and the other images that are being released tomorrow. So sleep well, everybody. Thank you very much again for being here, and we'll see you all tomorrow night. So until then, good night. Good night.
Bye for now.
Bye, everyone.
Thanks. Bye.